next in this section, we're going to be looking at solving absolute value equations, all different types of absolute value equations. You cannot just ignore the fact that there are absolute values in an equation. The absolute values are a game changer, okay? And so it talks to you about why they are a game changer, but in Table 1.2, they actually give you an outline on how to attack solving different types of absolute value equations. On number 1, it says if you have the absolute value of a number, okay, like, for example, absolute value of x equals 7, think about what are all the values of x that we'll check. Well, you not only have absolute value of 7 is equal to 7, you also have absolute value of negative 7 equals 7. That's why they say you're going to break those apart into two separate equations. We'll see that on our example below, on example 5. If on number 2, you should have something along the lines of absolute value of some quantity equals 0, you can just drop the absolute value bars in that case. That's what this is saying. You're only going to have whatever goes on inside the absolute value bars for you to turn out to be 0 for that to check. Now think about number 3. For number 3, if you have the absolute value of an algebraic quantity equals a negative, think about this. Absolute value of x equals negative 4. Is there a value for x such that you can take the absolute value of it and get a negative? I don't think so. That's why that situation you would have no solution. So heads up on that. And then if you have an equation with two absolute values, absolute value of, 3x minus 7 equals the absolute value of 2x plus 4. I just totally made those up right on the spot. They say how you're going to attack that is you're going to say one side equals the other side, no absolute values, and one side is equal to the opposite of the other side. That's going to take care of all the possible combinations such that you get values that would check using those absolute value bars. Okay, let's look at this example number 5. We're going to solve these two different types of absolute value equations. The first thing you always want to do when solving an absolute value equation is get the absolute value isolated on a side by itself. So I'm first going to subtract 2 from both sides. So we have 4 times the absolute value of 2t plus 7 equals 20. Now divide both sides by 4. So we have the absolute value of 2t plus 7 equals 20 divided by 4 is 5. Now, using number 1 in the table above, in table 1-2, this is one of those where we're going to split this apart into two different equations. One of the scenarios that would check for values of t is if the stuff 2t plus 7 would take on a value of 5. And so we're going to solve 2t plus 7 equals 5. And the second scenario that would check is if this quantity inside the absolute values, the 2t plus 7, would take on a value of negative 5. That would also check. What I'm saying here is that if this stuff was 5, it would check. That's going to be that first equation. But also, if this stuff was negative 5, with the absolute values there, it would check as well. That's this second equation over here. Now it's a matter of just doing a little bit of algebra to solve for t. So first of all, subtract 7 from both sides here. 5 minus 7 is negative 2. Divide both sides by 2. Divide by 2, divide by 2, right? So we have t equals negative 1. That's one of our answers. Over here, when we subtract 7 from both sides, we have 2t equals negative 12. Divide both sides by 2. Will give us a second value of t equals negative 6. There's the solution set for this problem. We have a negative 1 as an answer, and a second answer is negative 6. If you want to pause that and check each of those values, plop them back into t and see if they check, they will. But there's our solution set. Over here on number 42, first step is to isolate the absolute values. So I'm going to get that done by subtracting 7 from both sides. 6 minus 7 is negative 1. Negative 1 equals the absolute value of 9z minus 3. Now think about it, y'all. Don't just blindly break these apart into two equations, because no matter what you get for z in here, when you multiply by 9 by it and then subtract 3 and then take the absolute value, you're not going to get a negative, okay? Because that is a negative 1 over here, this is no solution. That is above in table 1-2. That's what number 3 was telling you, okay? So our solution set is the empty set.